Now watch this. If f covers G, then G is said to imply f. So if f is covering G means wherever G is having 1, f is already having 1. If f covers G, then G is said to imply f. So it is written like this, G is said to imply f. So what is the meaning of it is, from f we can derive G. It is not that from G we can derive f. So you just get confused here. When G is implying f, it means that whenever G is true, f is true, but the reverse is not true. Okay, about this implication we shall again discuss in this logic we have in discrete mathematics. There I will talk about it clearly, but you just understand here. So G implies f doesn't mean that whenever G, f can be derived from G. No, it means that whenever G is true, f is true, right? Just keep it in mind. Now we can also say it as G is a implicant of f, which means whenever G is true, f is true. So in digital logic or in general logic, whenever I say G implies f, it just means that whenever G is true, f is true. But we cannot derive the entire f from G, which means we don't know what are the truth values of f. We can only say that truth value of f must be true whenever G is true. Now what is the relation between this implicants? What is implicant? If a function is covered by other function, if f is covered by G, then f is called implicant of G. Or in this case, if f covers G, which means G is covered by f, then G is implicant of f. So now I'll just tell you what is the relation between the function, the expressions, and then the implicants. Let us assume that f is a function of 3 variables, a, b, c, and now the function is represented like this. The function f is a, b plus c, right? So what I did is I have written this entire all the min terms possible, and then I have shown you what AB is. So AB means all are zeros and only here there is 1 1, and C is nothing but the same C I copied here, right? So what you would think of is, now f is a combination of two functions. Let us say this is f1 and let us say this is f2. So therefore f1 is this and f2 is this, and f is a combination of f1 plus f2, right? So f is a combination of f1 plus f2. If you watch it, if you look at the f, now f is going to cover both f1 as well as f2, which means whenever f1 is 1, f will be 1. Whenever f2 is 1, f will be 1. Therefore, both AB and C are covered by f, which is AB plus C. Or you can even say it as both AB and C are actually implicants of f, right? So the terminology is, since f is covering these two, right? So these two are implicants of this, which means every function can be written as if all the product terms are implicants of the function. If I have a function like this, sum of products, right, or any sum of products, then I can take each product and I can say that each product is an implicant of the function, right? And now what is the relationship between each product and the function in terms of K map is, if you look at the K map, AB is this and C is this, right? So every product term can be written as a subcube here, right? Therefore every subcube is now an implicant of function. Now are you finding relationship? Every function is having product terms, therefore every product term is an implicant of f, because f is covering every product term, isn't it? And now every product term is also a subcube, therefore every subcube is an implicant of a expression. So now we derived that if you have a K map, then in the K map every subcube is an implicant of the function. Therefore how can you write a function as the sum of all these subcubes? Got it? Then what is a prime implicant is, see, every subcube is an implicant. Every subcube is an implicant. Now what is a prime implicant is? An implicant, so I'll just tell you informally what a prime implicant is. Every subcube is a prime implicant, which means this is a prime implicant, this entire thing is a prime implicant, as well as this is a prime implicant because it is a subcube, right? And as well as this is a prime implicant, right? As well as this is a prime implicant, right? And this is a prime implicant. These many prime implicants. Sorry, these are all called implicants, not prime implicants. So every subcube is an implicant. Now what is the difference between implicant and prime implicant is, so if you have a biggest implicant, then that is prime implicant, okay? And moreover, okay, watch this, I'll tell you. So among all the implicants, if a implicant is not a subset of any other implicant, then that is called prime implicant, which means if you call it as a prime implicant, then it should not be completely covered by any other implicant. So in terms of subcubes, we can say it like this: a subcube is said to be prime implicant if it is not present as a part of any other subcube, right? So in this case, if you see all these implicants, these are present as a part of some other implicant, therefore they cannot be prime implicants. So only there are two prime implicants. What are they? This entire 4, a cube of 4, that is a prime implicant, as well as this cube of 2, that is a prime implicant. Why? Because these two cannot be part of any other implicant, and moreover this entire thing cannot be a part of any other implicant. Now in terms of this product terms and in terms of this subcube, both of them we shall define the prime implicant. See this: an implicant P of f is said to be a prime implicant if P is a product term. First of all, it should be a product term. Why? Because it has to be a subcube, right? So product term. And second is, deletion of any literal from P results in a new product which is not covered by f. So what does it mean? If you try to delete any literal, so how can you delete a literal? If you delete a literal from a product term, let us say I have here AB. Now if I try to delete A or B, what happens is we are actually increasing the subcube, right? We cannot increase the size of the subcube because we are getting more cells into the subcube, and those cells may not be present in the function. Therefore, if you try to delete any literal from P, then we are going to get a term which is not covered by f, right? So if that is not the case, what is this meaning of this in terms of subcube is, if we have a subcube, then that should be the longest subcube possible, which means this subcube should not be part of any other subcube. So what is a prime implicant? It should be a subcube, and second thing is it should not be a part of any other subcube, which means it itself should be the longest subcube possible, right? That is called prime implicant. So now we have seen what is an implicant. What is an implicant? Anything that is covered by a function is called implicant. So in this function, these two are implicants. Now coming to the table K-map, these implicants turn out to be the subcubes, right? And these subcubes, if they are the biggest subcubes, they are called prime implicants. Simple. Now we shall define what is essential prime implicant, and then we shall see how to minimize the function, right?